Okay, welcome back. For the last tutorial, we are looking at errors and how we quantify my errors. We looked at four ways. The first one was to look at absolute errors, and then we looked at mean absolute errors, the relative errors up to percentage error. Now we are continuing with error propagation. Error propagation is about combination of errors. Let's suppose you are doing addition, subtraction, multiplication, or division of errors. How do we combine errors when you are adding two different quantities? And if you are multiplying different quantities, how do you combine the errors? So that's what we want to look at. We'll start with addition or subtraction. So on spellings, bear with me. Subtraction. So we are saying let x be a plus b or a minus b if the measured value of the two quantities are a and b. So this a, it's a measured value, and also this b, it's a measured value, such that these measured values a and b have errors which are absolute errors, change in a and also change in b for a and b respectively. Then in order to find the maximum absolute error in their addition or subtraction, then the error is just a summation of the absolute errors. So what this statement is talking about, tilinde a, which is a measurement, and this measurement is composed of a measurement a and a measurement b. Measurement a has error which is change in a as absolute error, and measurement b has an error which is change in b as the absolute error. So now if you want to add these two measurements, you want to add measurement a plus b. In a normal addition, a plus b will be equals a plus b. For example, if a was 5 and b was 4, then would a plus b would be 9. So that's normal. Now the error in the measurement, if you want to quote the error for this a plus b quantity, the error now becomes summation of the absolute errors in the measurement. So you just add change in a plus change in b, you find the error combined. Similarly, when you are subtracting the measurement a minus b, a minus b, the error in the measurement becomes also the summation of the errors. So it doesn't matter whether you're adding or subtracting, the combined error is the sum of the absolute errors. Okay, let's take a proper example. Suppose two cars. Suppose two cars are going in the same direction at a speed of 2 plus or minus 2 plus or minus 0.1, and the other car at the speed of 3 plus or minus 0.1 meters per second, and also this meters per second. Suppose two cars are going in the same direction at this speed, 2 plus or minus 0.1, and the other car at a speed of 3 plus or minus, let's take 0.2, there should be different values, 3 plus or minus 0.2. So the question is, was the difference in speed between the two cars? So to answer this question, you see kunena kuti vutoi pali ma speed awiri, and each speed ili ndi error yake. Speed for the first car in the area 2 plus or minus 0.1, which is plus or minus 0.1, and the speed for the second car in the 3 plus or minus 0.2. So if you want to find the different speed between the two cars, it means that we'll subtract the speeds, and when you want to quote the error, you add the errors. So the different speed will be equal to 3 minus 2 now in terms of the error in measurement, it will be also the summation of the absolute errors. So that's what basically the statement is talking about. So our answer will be 1 plus or minus 1 plus or minus 0.3. So that's the answer. So whether you are subtracting or you are adding, the error in the measurement is always added. Whether you are subtracting or you are adding more quantities, the error in the measurement is always added. So this is error which we have got in this measurement. Now, the second law, it's a law of multiplication and also division. So they also go together. The law of multiplication and division says, let's suppose we have the measured value A and B, and these values may be multiplying or may be dividing each other. So if the error in A is changing A and the error in B is changing B, like the previous one, then the error in terms of multiplication and division becomes the sum of relative errors of your measurements. The error in multiplication or division becomes the relative error in your measurements. Remember, from addition or subtraction, we were taking the absolute error. That's in addition and subtraction. timatenga absolute error. But in multiplication or division, we are taking the relative error. And from the previous tutorial, remember that the relative error is the mean absolute error divided by the true value. That's the relative error. It's the mean absolute error divided by the true value. Now, in this case, if you look at A and B, if you are multiplying, the answer in the measured value, it will be A and B. But your error, you'll be summing the relative errors of A and B. So for A, the relative error is just this error divided by its true value. And this error is what we are calling it as the mean absolute error. So it's the mean absolute error divided by the true value. So this is what is expressed here. The absolute error divided by the true value, that's a relative error. And in B, it's also the absolute error in B divided by its true value. So if you add this, changing A over A plus changing B over B, what you are getting is an error in the multiplication or division. So whether you are adding or dividing, you add the relative error, but you do the normal addition. Whether you are multiplying or dividing, you add the relative error, but then you do the normal multiplication and division for the measured value. Yeah, let's have one example. I'll just copy this formula into the next slide. Just copy it into the next slide. So this is a rule for multiplication and division. And let's say now go to the value, let's say we have the mass of an object. Mass of an object is given as 2 plus or minus, I'll just copy this for simplicity's sake, 2 plus or minus 0.4, and the acceleration due to gravity is 3 plus or minus 3 plus or minus 0.1. Let's say that we are given this scenario, and the question is find force or the weight of the object. Find force or the weight of the object. Now to tackle this question, we know from the laws of motion, and basically from this, the first law, that force is a product of mass and acceleration. This should be, is it? Yeah. The second, is it the second law or the first law? So force is a product of mass times acceleration, which is just force equals m times a. So this is a formula which we have in terms of force. But if you look at our example, you see that mass is 2 plus or minus 0.4, and the acceleration is 3 plus or minus 0.1. Now we are saying the error in the measurement. You do the normal multiplication for the measured values, which is 2 times 3. But now, in terms of quoting the error, it will be now in terms of relative error. The error, it will be in terms of relative error, which will be the change in error for the first value divided by its true value plus the error for the second value divided by its true value. So the error for the first value is 0.4 and its true value is 2, and the error for the second value is 0.1 and its true value is 3. Now when you complete the mathematics, you find that the answer is 6. The answer is 6 plus or minus the summation of the two values. And if I just take this value, or you can do it directly to find the sum, okay, which is 0.4 divided by 0.2 is divided by 2, it's 0.2 plus 0.1 divided by 3, 0.1 divided by 3, so it's 0.0333. If you add this value with 0.2, you get an answer which is 0.23. So the answer now becomes 6 plus or minus 0.233 as the error in the measured value. So whether you are doing multiplication or division, this is a process. You multiply if the measured values are being multiplied, but you add the relative errors. You divide if the measured values are being divided, but you add the relative errors. So the law is the same as for multiplication. It just differs on the original value. Okay. Now on the same rule, maybe you will not find it in these notes, but we can talk about it. It's concerning powers. So what do you do if a certain number is raised to a certain power? What happens when a number is raised to a certain power? So let's look at this example in which we have a value of a x which is raised to the power n. so raised to the power n. Now if x is raised to the power n, what it means is we are multiplying x to the n values. For example, if I take 2 raised to the power 2, I should take raised to the power 3. What it means is I should multiply 2 by 2 by 2, like multiplying 2 katatu. So if you look what is the rule of powers, it's the same rule of relative errors, because relative errors says when you are multiplying the numbers with the different errors, what you do, you add the relative errors. So if 2 raised to the power 3 had an error, and that error was 0.1, so 2 to the power 3 plus or minus 0.1, the error in this measured value, it will be 2 plus or minus 0.3, and because we have the error 0.1, we'll be adding the relative error, which is 0.1 over 2 plus 0.1 over 2 plus 0.1 over 2. So it's the same rule tayonage. You add the relative errors, in which the relative error will be the error divided by the true value, and our true value is 2 and our error is 0.1, so it will be 0.1 divided by the true value, which is 2, plus 0.1 divided by true value, which is 2, plus 0.1 divided by true value, which is 2. In that case, you get the error in this measured quantity. Now to simplify the matter, I'll write an equation which may seem complicated, but the concept is the same. To simplify the matter, let's say we have this kind of function, x raised to the power n plus or minus an error, which is, let's say this error is m. This error is m. Now the formula in terms of propagation of powers now becomes n multiplied by the x plus or minus it will be x to the power n, x to the power n plus or minus n, then the error, which is m, divided by our true value, which is x. So it is the same as this number, in which our n now is 3, so it will be 3 times the relative error. So it's the same. Now if you simplify the above fraction, you see that if I take this and paste it here, you see that this 0.1 over 2 plus 0.1 over 2 plus 0.1 over 2, when you factorize it, the 0.1 over 2, you see that there are 3 0.1s. There are 3 0.1s, so I will factorize plus or minus 3 0.1s, 0.1 over 2. If I simplify that, it will be like this: 8 plus or minus 3 times 0.1 over 2, which is the same as this fraction. Which is the same as this fraction. Okay, so that's normally the formula when you have a number which is raised to a certain power. The error, you multiply the relative error with the power in which you are raising your number, but then the number itself is raised to the power. And this is an example. You can review it and follow it. If you have any questions, then tita magambirana offline.